So we have the first step. So in okay, we are given this circuit here. So they want us to determine the current between x and y. So where is x and y? We have x and y. So another way, they want us to determine the current crossing this load. So this current is called line current. So they want us to proceed using Norton theorem. So Norton theorem consists of simplifying a complex circuit into this form here. So we need to have this form. So we have the source of current, which is called Norton current, which is in parallel with a resistor. So that is called Norton resistor. And then here we have the terminal x and y. So I need to simplify this complex circuit into this one. So if we only know what the Norton current is and the Norton resistance is, then we are fine. But there is a procedure to determine IN and RN. Okay, let's start with the Norton current, which is symbolized by RN. So to determine the Norton current, we need to close the load. So in other words, so if I represent this circuit here, I need to have, so I will just, okay, so if I need to represent this circuit with a load that is closed, so I have my values. So the value of the resistance, so we have 20 ohm there, 5 ohm, 5 ohm there. So now across x and y, so I need to close this circuit. I need to remove my load resistor, and then I replace it by a conductor. So in other words, I need to close, I need to short circuit the load. So that's the first step. So now from this circuit, I'm gonna need to determine the current flowing in this portion. So that's gonna be called Norton current. So how to determine the current in this portion? So I first need to start from the beginning. I'm given a source of voltage, and then I have the resistors. So I'm gonna do the procedure that we have used previously. So voltage division, ohm laws, current divisions, all these procedures. So I need to apply it here again. So in order to get this current, I first need to determine the current from the supply. So I first need to know my total current. So how to determine the total current? To determine the total current, I'm gonna need to use Ohm law. So current is equal to voltage, so I'm gonna need to use the total voltage, which is 40 volt, which is also my supply voltage divided by the total resistance. So if I'm considering this to be my supply, so to get the total resistance, I'll always start from the opposite side. I can say that these two resistors are in series. So these two resistors are in series, so I can replace it by 1. So now this, I'm gonna say that, so I first need to, so the objective is to determine R total. So I'm gonna say R total. How can I determine R total? If I look these two resistors, they are in series. So we have the resistance of this block, the entire block here, will be equal to 5 plus 5, because these two 5 are in series. So now this block is in parallel with that resistor. So in other words, we are going to say that the resistance of this block here, as we can see, this block and that one are in parallel. So we just use the notation. So we say the green block is in parallel with the 20 ohm. So now we can see that the blue block is in series with these two resistors. So we have the first resistor, the second, and the third. So we are going to have, so we first close. Once we close, we determine the value of the green block. So now we're gonna need to determine the total resistance. So as we can see, these two are in series with the green block here, the blue block. So we need to add 10 and this 10 and that 10 to get the total resistance. So now we just need to compute this. So I'm gonna say that gives, so if I always start from the inside, so I have these two, so the value of these two is 10, so that 10 is in parallel with 20, and then I say plus, so I can just add these two, I get 20. So if I continue, I'm gonna get 1 over 10, so I can replace this bracket with 1 over 10 plus 1 over 20, and then the inverse, and then I say plus 20. So the value of the resistance, the total resistance, is 1 divided by 10 plus 1 divided by 20, and then the inverse. So I get 6.76 ohm. So that is the value of the total resistance. So I need to determine the current, the total current, because in order to determine the Norton current is the current flowing in this portion. I first need to have that current, so that I'm gonna use the current division theorem to determine IN. So now I'm gonna find I total, which is equal to the supply voltage, which is 40 divided by the total resistance. So here I've realized that there is a typical mistake. So we need to have 20 6.666 and 7 ohm. So we also need to rectify this part. So the current will be 40 divided by 26.6 ohm. Sorry, we have 1.4999 and so on amp. So that is the current, so that is the supply current. So if I have my supply current, I can determine the current in this branch, because the current in this branch is the same as the current in this branch is the same as the current in this branch, because all these are in series. So I have this branch which is in series of this branch which is also in series of this branch, so we have the same current. So how to determine the current in this branch? I'm gonna need to apply the current division theorem. So I'm gonna say that the current in this branch is the Norton current. So the Norton current is given by, so here I'm gonna need to use the supply current, and then I multiply by, so I have the supply current which splits into two branches. So we have the first branch and the second branch, but I'm concerned to calculate the current in the second branch. So the resistance of the second branch is that one, and the first branch is the resistance of the second of the first branch is this one. So we have two resistors that are in parallel. So at the bottom I'll first need to add them. So I have 20, and the value of this resistor is 10. And on top I'm gonna need to use, because as I'm calculating the current flowing in this resistor, I'm gonna need to use the opposite. So the opposite resistor is 10. I mean it's 20 ohm. So I need to put my 20 on top. So what's gonna be the Norton current if I calculate? So I have the supply current multiplied by 20 and then divided by 20 plus 10. So I get 0.999999875 amp. So that is the Norton current. So I have the Norton current already, so which is that one. So now I'm gonna need to find the Norton resistance. So I'm gonna do it in the next slide. So we are doing, so we finish step 1. So we also need to remove this. So now we need to do step 2. So we need to calculate the resistance of Norton. Right. So the resistance of Norton, or Norton resistance, is symbolized by Rn. So to determine Rn, we need to do the following. So we first need to remove the load's resistance. So we need to remove this. So if we remove it, we are going to have X and Y there. So there is nothing here. And then we need to close the voltage source. So here we have 5 ohm, and then here we have 5 ohm. So we have 20 ohm, and then we have 10 ohm, 10 ohm again. So now here we don't need to repeat that source. We need to have a closed circuit. So now we're gonna need to calculate the resistance between X and Y. So that resistance will be called Norton resistance. So how to determine the total resistance, so between X and Y? So I always start from the side which is located away from the terminal. So if I move from the opposite side, I realize that these two resistors are in series. So we have these two which are in series. So I can replace the blue block by a single resistance. So that single resistance will be the sum of these two, because they are in series. So 10 plus 10 gives 20 ohm. So now that's this 20 ohm, if you look properly, in other words, this block is in parallel with that one, this resistance. So I can find the resistance of these two. So I have the first resistance and the second resistance. So the resistance of these two, since they are in parallel, so we have 1 over 20 plus 1 over, so that is also 20. So the first 20 is that one, and the second 20 is that one, and then the inverse. So we get, so if we compute this, we are going to have 10 ohm. So the resistance of the green block, okay, let me just use the green color, it's gonna be fine. So we have 1 over 20 plus 1 over 20, the inverse. So we get 10 ohm. So 10 ohm is the resistance of the green block. So now if you look at this green block, it is in series with that resistor and that one. So since they are in series, then to find the total resistance, we'll just say, so that total resistance will be called Norton. So it's the resistance between X and Y, which is equal to 5 plus the resistance of the green block, because they are in series, plus that 5 again. So we have 5 plus 10 plus 5. So that's my first 5. I have 10, which is the resistance of the green block, and then I have 5, that one. So I end up with 20 ohm. So now I have everything that I need. So I have the Norton resistance and the Norton current. So now if I go back to the previous section, so I need to simplify this circuit into this one. So in other words, I need to find IN and RN, but I have already all these two values. So now I can replace and then calculate what they want me to do. So I'm gonna go to the next slide. So this circuit is simplified too. So we have the Norton current. We know the value already, so we can say IN is equal to, from the previous slide, I have my IN. So that is very close to 1. 0.9999 is very close to 1. So I will just say IN is equal to 1. So I have 1 amp. So that is the Norton current. When we use Norton, we need to make sure that we have the source of current should be in parallel with the Norton resistance. So we have determined the Norton resistance here, which is equal to 20 ohm. So we have 20 ohm. So this step consists of, so that is step 3. So I need to find the line current. So this is the equivalent circuit of Norton. So in order to determine the line current, we need to plug the load. So the load is, because they want us to determine the current in the load, because it's clear here. Let's say find the current in X and Y. So at these 2 points we can see that the load is connected. So in other words, they want us to find the current across this load, I mean the current flowing in this load. So I'm going to plug the load back. So we have 5 ohm, and then here we have X and Y. So now here we just need to apply a simple current division to determine the current flowing in this load. We realize that, so we have the supply current, which is 1 amp, is the Norton current. So at this point we have one current flowing, one portion of current flowing in this resistance, and another portion flowing in this resistance. So we need to find the current in X and Y. So in other words, we need to consider this current here. So I'm gonna use the current division. So to find, so I'm gonna call it IL. So which means the line current. So I'm gonna say IL is equal to, so I need to use the supply current. So the supply current is the Norton current, which is IN and then multiply by, so we have the value of these two resistors. So that is called the load resistor, and that is called Norton resistor. So we need, at the bottom we will need to add these values. So we have RL and RN, and then on top, since we need to determine, since we are tasked to determine the current flowing in 5 ohm, then we need to use the opposite resistor. So we need to use the other resistance, which is 20 ohm. So we need to use Rn on top. So in other words, I have the value of In, which is 1, so which is 1 amp, and then I multiply by, I have the value of the load resistance, which is 5, and then I have the Norton resistance, which is 20. So on top I need to use the Norton resistance, because we are determining the current in this branch. So I need to use the opposite. So now if I compute this, I'm gonna get 20 divided by 5 plus 20. So I get 0.8 amp. So that is the value of the current in between X and Y. Okay, that's it.